In this video, I will explain how to find Hamiltonian paths and Hamiltonian circuits in graphs. So let's start with a couple quick definitions. A Hamiltonian path walks through a graph using each vertex exactly once. Now, a Hamiltonian circuit is a type of Hamiltonian path that starts and ends at the same vertex. So I have three graphs down here. Let's take a look at each one and see if we can find Hamiltonian paths and circuits in each of these graphs. So if we consider this first graph here, to determine if a Hamiltonian path exists in this graph, it means let's pick some vertex to start with. So let's say vertex A, and let's see if we can walk through the graph using edges and see if we can visit each vertex exactly once. So for example, if we start at A and then we walk to vertex B right here, then let's say we go to vertex C, then to D, then to E, this is an example of a Hamiltonian path because we visited each vertex one time. So let's go ahead and write down that path. Alright, so I've abbreviated it as H path for Hamiltonian path. We went from A to B to C to D and then to E. So one thing that we'll notice about this Hamiltonian path that we just made is that we didn't visit every edge in the graph. So for example, this edge right here did not get used, and that's okay because a Hamiltonian path only cares about visiting each vertex in the graph one time. So that's in contrast to an Euler path, which I have another video about. But an Euler path is where you walk through the graph and you use each edge exactly once. So a Hamiltonian path doesn't care about edges, it only cares about vertices. And it's worth mentioning that there are often multiple Hamiltonian paths in a graph. So this was just an example of one. Another example would be if we started at vertex E, we could go to D, C, B, and A. That's another example of a Hamiltonian path. Or if we started at E, we could go to D, then A, then B, then C. That's another example of a Hamiltonian path. So often if one Hamiltonian path exists, multiple of them usually do in a graph. Now for this example, we'll notice that there are no Hamiltonian circuits. In other words, there's no way to start at a particular vertex, walk through the graph and visit each vertex once and end back at the same vertex. So only a Hamiltonian path exists for this particular graph. All right, now let's check out example number 2 right here. So let's see if we can find a Hamiltonian path and a Hamiltonian circuit. So again, let's start at vertex A here, and let's see if we can walk through the graph and visit each vertex once. So let's say we go to B, then we go to C, then E, then D. This would be a Hamiltonian path where we visited each vertex one time. But we'll notice if we go from D back to A, we can create a Hamiltonian circuit. So that's where we started at A, we visited each vertex once, and we ended at A. So this graph has a Hamiltonian circuit. So let's write down that circuit. So here's the Hamiltonian circuit that we just found. Now again, for this one, there's actually multiple Hamiltonian circuits. So for example, let's say we start at vertex D instead. We could go to C, then E, then B, then A, then back to D. That would be another example of a Hamiltonian circuit. And once again, you'll notice that there are some edges that we don't visit in some of these Hamiltonian circuits, and that's okay because again, we only care about visiting each vertex one time. All right, now let's check out this very last example, graph number 3 here. If we attempt to find a Hamiltonian path or Hamiltonian circuit in this graph, we'll find that none exist. So for example, if we start at vertex A, let's say maybe we go to D and then to C, but if we go back to D, that violates the rules of a Hamiltonian path. We can't visit a vertex more than once. So you'll find that if you just kind of work through this graph, so if you, let's say, start at vertex F instead, maybe we go to B, then E, then D, then A, you'll quickly find that there is no Hamiltonian path that exists. There's no way to walk through this graph and visit each vertex only one time. So for this example, no Hamiltonian path exists, and by definition, no Hamiltonian circuit exists either, since a Hamiltonian circuit is just a type of Hamiltonian path. So for this example, we'll just write no Hamiltonian paths. So those were just 3 quick examples of how to determine if a Hamiltonian path and a circuit exists in a graph.